you remember to record?
I just said that, so no prizes there.
I'm sorry.
Ow. Ow.
You good?
I just burped through my nose. It really hurt. Okay. So today we're talking about matrix inverses. What is an inverse? Well, it's just a matrix that gives us the identity matrix when we multiply it. So for numbers, right, numbers also have inverses. For example, the inverse of 2 is just 1/2. That's because when they're multiplied together, they give us 1. Or the inverse of 5 is 1/5, because when multiplied together, we get 1. Okay? So the inverse matrix is defined as the matrix that when multiplied by it, it returns the identity matrix. And we learned last time what the identity matrix is, right? It's just a matrix that has, all entries as 0 except the diagonals, which are 1, right? So that is the 4x4 identity matrix. Quiet, please, guys. And so the inverse matrix has the properties such that when you multiply it, it gives you back the identity matrix. And this can be done in either order. So A inverse times A is equal to I, and A times A inverse is also equal to I, the identity matrix. All right? Okay, any questions? Guys, be quiet. So some properties you need to know. Only square matrices have inverses. All right, square matrix has the same number of rows and columns. And some also don't. So some matrices are invertible, and some matrices are non-invertible, meaning that you can't have an inverse. Okay?
Some square matrices don't.
Some square matrices don't have inverses. Yeah.
In what case would they not have an
You'll see. Okay, let me show you guys the process for how we find inverse matrices, okay? Finding inverse matrices. So when we find inverse matrices, this is the process. If we wanted to find finding the inverse of A, let's say, what we do is we write a big matrix with A on the left side, and then on the right side we put the identity matrix of the corresponding size, okay? So if A is the 3x3 matrix, then we put I, which is a 3x3 identity matrix next to it. All right? Guys, I would take notes, maybe you would. Never mind.
Think about that big survey when you're talking, Mr. Nye.
What?
I don't consult with students.
Well, I didn't say anything, did I? Okay, the process is we perform Gauss-Jordan elimination, which we just did on our quiz, right? We perform Gauss-Jordan elimination on this matrix, this big matrix, such that the left side, we try to turn it into the identity matrix. And if we do that, then the right side will automatically turn into the inverse matrix of A. Okay? So if we perform row operations such that the left side becomes the identity matrix, then the right side will automatically become the inverse matrix of A, assuming that we perform the same operations on the right side as well. Got it? So we can do an example. Any questions? Let me give you guys an example.
Can you let us try and solve these?
I don't think you guys would be able to, so let me just do it out for you guys, okay? Where is my example? Here it is. Okay, let's say we were asked to find the inverse of A, where A is equal to this matrix here. 1, minus 1, 0, 1, 0, minus 1, 6, minus 2, minus 3.
Shouldn't it be -1? Not -1.
Minus 1?
Shouldn't it be -1?
I'm allowed to say minus 1?
Wait, is it like you switch the horizontal particle?
Nope. That would be a transposition.
Wait, what does it mean? Where A? When is
It's just what people say. Okay, so what you do is you write A on the left side of this matrix. So you put a matrix like this. And then on the right side, you just simply write the corresponding identity matrix. So that would be 1, 0, 0, 0, 1, 0, and 0, 0, 1, right? Got it? So we put A on the left side and I on the right side. And then what do? And then we try to perform Gaussian eliminations on the left side while also doing them on the right side as well, such that the left side becomes the identity matrix. So that's what we're going to do. So I'm going to replace row 2 with row 1 minus row 2. I'm using my new method that I sent out in the email. And then I'm going to replace row 3 with 6R1 minus R3. Right? Because that's going to give me a 0 because these will cancel. So I'm going to keep the top the same. All right, Kellen, you're going back to the back. Ruhan, you were promoted. You're less talkative. Not by much, though. So, okay, so R1, I'm replacing the second row with R1 minus R2. So that's 0, minus 1, 1, 1, minus 1, 0. Right? I just subtracted row 1 with row 2. So row 2 is replaced with R1 minus R2. So 1 minus 1 is 0. Minus 1 minus 0 is minus 1.
Oh, so you just minus, like you add like A and then you add like the Gaussian like
Yeah, I'm just doing Gaussian elimination on the left side.
on the left. So you add them, but you don't add them, but like you combine them and like try to convert it.
Yes. Okay, then the third row is going to become 6 times 1 minus 6, which is 0. Negative 6 plus 2, which is negative 4. Okay, I'm just going to go really quickly here because you guys know how to do this already. So just trust me, you know. Just trust me. Okay, so the very important thing that I'm doing is that whenever I'm doing any row operation on the left side, I'm also doing it to the right side. So that's the main idea. I'm going to keep going. I'm going to kind of speed through this because this is boring, right? 1 minus 1, 0, 1, 0, 0. I'm also going to invert this second row to make that into a 1. And then the third row, I'm going to do 4R2 minus R3. So the second row becomes 0, 1, minus 1, minus 1, 1, 0. And the third row is going to become 0, 1, minus 2, minus 4, 1. Yeah.
Is that at the bottom? Is that 4 row 2 or 4 row?
Why are you
4 row 2.
why are you multiplying R1 minus R3 by brace?
Because I want to make this turn into a 0.
Yeah,
I do 6 times the first row and then subtract the third row.
Oh, you subtract.
Okay? So this is now successfully in row echelon form.
Can you also add it?
You could, but you wouldn't get a 0.
But you would use negative.
Sure. Multiply by -1 and then add. Okay, so now we're in row echelon form. I need to keep going because I need to get into a reduced row echelon form, which just gives me the identity matrix, right? So I need to turn these both into 0 as well.
Take third row, add it to
Okay,
second row.
good. So I'm going to rewrite this matrix. And then I'm going to replace the second row with R2 plus R3. Row 1 is going to stay the same. 1 minus 1, 0, 1, 0, 0. And then the second row becomes 0, 1, 0, minus 3, minus 3, 1. Okay, I combined row 2 and row 3. And then the third row will stay the same. Okay, just a bunch of computation. You guys know how to do this. And then I'm going to replace row 1 with the sum of row 1 and row 2. Right? Because that will cancel out the -1 here, which I want. So row 1 becomes 1, 0, 0, minus 2, minus 3, 1. And then the bottom stays the same.
Would you also try to do the right side too?
Nope, because now I'm done.
No?
The right side is simply the inverse matrix that I wanted.
Oh.
Because the left side has turned into the identity matrix, right? So now I can happily write that the inverse of A is equal to -2, -3, 1, -3, -3, 1, -2, -4, 1.
So you put it together, and then you make this first half row echelon.
Reduced row echelon form.
So then it flips the other side.
Yep.
Ah, got it.
I got it.
Okay. Anybody need to see this more?
We're too fast.
I know you guys can't follow it because we already learned this, right? But I'm just showing you guys the process.
I just can't do mental math that fast.
It's okay, you can go slowly too. I know. But we're, Okay, any questions about the process?
How fast should we be able to do these?
Bro, you don't want to ask him that, bro. Because he's going to say like 2 minutes, and we took 30 minutes for a fifth. But now we have 6 numbers.
Okay, let's keep going. Okay, we can check this. We can verify that this indeed gives us the identity matrix when we multiply it. So we can check A times A minus 1. All right, A is just 1, minus 1, 0. 1, 0, minus 1. 6, minus 2, minus 3. And then we can multiply that by inverse of A. Okay. If we multiplied A by the inverse of A, you could check at home that we get the identity matrix. So this is kind of combining what we've been learning in the first 2 lectures with the third lecture, right?
Wait, I missed every step.
It's okay, as long as you understand the general process,
It's just
okay? It's okay.
we're too fast.
I know.
No, it's not -4. No,
All right, any questions about the general process? Are we good?
Take go up.
Okay, which slide?
Did you record?
Go up. Jeez. Okay, so you just reduced it to like the actual.
Yeah, that's right. All right, I'll keep going. I trust that you guys understand the process, even if the steps were a bit fast. Okay, next and lastly, we just need to learn a quick formula. Quiet, please, guys. formula for finding the inverse of a 2 by 2 matrix. So thankfully for 2 by 2 matrices, there is an easy formula that allows us to not have to go through this process. Okay, here's the formula which you guys do need to memorize. If we have a 2 by 2 matrix ABCD, the inverse is 1 over AD minus BC. And then you multiply that by D minus B minus C A. Okay?
Find it to be faster.
I mean, it's easier because you don't need to do Gaussian elimination. You can just quickly write it out. It's just a hard formula to memorize, but you guys will memorize it. Even I've memorized it after 10 years, okay?
I feel like you would memorize that.
Like, I still remember it from pre-calc 10 years ago. That's what I'm saying. Okay.
See, I know.
So some important vocabulary. AD minus BC is also called the determinant, which we'll learn next lecture more. Okay, AD minus BC. Just memorize that. That's the determinant of a 2 by 2 matrix. And then the easy way to memorize this is by just thinking, okay, top left and bottom right, they switch. But top right and top left and bottom left, they become negatives. Okay? So just remember that. Top left and bottom right switch, and top right and bottom left become negatives.
So they switch places.
That's right. Any questions? Let me show you an example.
Let us solve yes.
Okay, find the inverse. Sorry. Find the inverse of 1, 2, 3, 4. Can we do that?
Dog ran across.
Find the inverse of 1, 2, 3, 4.
Is it? Wait,
Quiet, please. Don't talk about things other than this stuff.
is it 4, negative 3, 2, 1?
No,
No?
you didn't do the fraction.
Oh, I have to do the fractions.
Okay, so you first calculate the determinant, AD minus BC, and then you take the reciprocal of the determinant and multiply that by the new matrix. Okay, so this becomes 4 minus 6, 1 over 4 minus 6, times 4 minus 2 minus 3, 1. Right? The top left and bottom right switched, and the top right and bottom left became negatives. You would have to multiply it out. So this is negative half times that matrix. So this is equal to negative 2, 1, 3 halves, negative half.
Wait, sorry, real quick, Mr. Nye, how did you get how did you get 2 over 3 and negative 1/2?
Oh,
I just multiplied it, right? This fraction is equal to negative half. And so I multiplied every number by negative half.
Wait, can you say that again?
I multiplied every number by negative half because the fraction is equal to negative 1 over 2. Okay. Any questions? Guys, be quiet. Think, don't talk, okay? This class would be easier for you if you did that.
See, I'm
Wait,
thinking,
can we take a picture of this?
You can just watch the video, but sure. Okay, let me also show you an example. Be quiet, please. Let me show you an example of a matrix that does not have an inverse. A matrix will not have an inverse whenever the determinant is equal to 0. So 1, 2, 2, 4 does not have an inverse. Why is that? Because when we calculate the determinant, which is AD minus BC, right? It's going to be 4 minus 4, which is 0. So that's not allowed. It's undefined. So it's 4 minus 2 minus 2, 1. And we would say that this matrix is not invertible. Non-invertible. Okay?
Zero's undefined.
Is that because zero just equals 0?
No, that's because it's undefined.
Oh yeah, sorry.
1 over 0 is
0
undefined.
undefined.
Yeah.
Yeah.
Any questions?
Yeah, I know. It's just.
This guy is.
Okay, well, you guys really only need to know 2 things from today, which is how to do an inverse matrix with Gauss-Jordan elimination, and secondly, what's the formula for a 2 by 2 inverse. So I think it's pretty straightforward.